Page 21 of complex numbers and polynomials. In number 1, it asks us to find all the zeros of these cubics and quartics. The way you would do this completely without the calculator is you would use what's called the rational roots theorem, and this is not part of the syllabus, but I'm just going to go through really quick because you might have to learn it later, and it's good to have a good idea that this exists already. Of course, like now that we have calculators, it's not as commonly used anymore. This was taught as part of Math 10 and extension. Basically, we can use like a variation of the fact that this number is a multiplication of all the roots. It's related to the multiplication of all the roots, especially if this coefficient is 1. And it's called the rational roots theorem. And the rational roots theorem tells us that that we can find a root by listing all the candidate roots, and the candidate roots are going to be the last constant divided by the first coefficient factors. So let's say that the factors that produce the constant 1, the whole number factors that produce the constant 1 would be -1 and 1. And the factors that would produce the coefficient positive 1 would also be -1 and 1. How could it be -1? -1 times -1 is 1, right? So we know that among the roots of x cubed blah, 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 we would have possible candidate roots as 1 divided by 1, 1 divided by -1, -1 by 1, etc. So basically, if we divide these factors by any of these factors, the two possible numbers we get are going to be plus or minus 1, right? So now that we know that among the factors there could be positive 1 or -1, we are going to try to either use 1 or -1 in synthetic division and see what we're left with, okay? So we're going to try 1 first because that's kind of easier. And then we'll write the coefficients out. And then we'll bring down the 1 and we'll multiply by 1, add, multiply by 1, add, multiply by 1, and no. So 1 is not a factor. So let's try -1. Okay, so we have 1, -3, -3 and 1, 1, multiply by -1, add, multiply by -1, add, multiply by -1. And -1 is a factor, okay? So we found that for A, one of the factors is -1. Now we're going to try and find the other factors, and the way we can do that is we can take what's left over here from the synthetic division, and we can say that that is the quadratic that is remaining after we divide by the factor x minus -1, which is x plus 1, right? So one of the factors is x plus 1. What's left is x squared minus 4x plus 1. And let's see, if we do the discriminant on this, b squared, which is -4 squared, minus 4 times 1 times 1, we get 16 minus 4, which is 12, square root of 12. So it's going to be irrational roots. So we're going to have to use quadratic formula. So it would be negative b, which would be -4, plus or minus square root of b squared, which is 16, minus 4 times a times c, which is -4, divided by 2. So that's equal to positive 4 divided by 2, which is 2, plus or minus the square root of 12 divided by 2. We could simplify that into 2 plus or minus 2 square root of 3 divided by 2, which is which is square root of 3. So we want to find the zeros. So one of the zeros is -1, and the other two zeros are 2 plus or minus square root of 3. Okay, and so we did that kind of like totally without the calculator, even though you know, in the solutions in the book, they actually expect you to use technology to find the first root so that you don't have to use rational roots theorem. Okay. All right, but I just wanted to show you how to do it completely without the calculator if you have to someday. Let's look at C. This one's a little bit more challenging because it's got 2 and -35 instead of just 1 and -1. So if I was to list the factors of -5, the whole number factors of -35, I would have plus or minus 1, plus or minus 5, plus or minus 7, and plus or minus 35, right? And for 2, I would have plus or minus 1 and plus or minus 2. Okay, and when we generate a list of all the possible zeros, we would have like plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 35. We would have plus or minus 5 divided by 2, plus or minus 1 divided by 2, plus or minus 7 divided by 2, and plus or minus 35 divided by 2. Those are all the possible zeros, okay? And usually when we start looking for zeros, we're always going to start doing synthetic division with plus or minus 1 because, first of all, there's a good chance that that's it. Second of all, it's the easiest thing to do synthetic division with, okay? I'm not going to do that because you're not expected to know that for the exam, but you would just do it the same way we did it here, okay? So let's use the calculator, and if we use poly-SMLT, we are actually able to find every single root at the same time. But just so that we do part of this manually like the book expects you to, I am going to use graphing instead, because graphing, of course, only gives you the real roots. So I'm going to put 2x cubed minus 3x squared minus 4x minus 35. And then I'm going to graph it, and I'm going to see where there are intersections with the x-axis. There's one right there. Okay, let's do zoom fit. Zoom fit, and then we'll see that that's not a straight line, it's a curve. Okay, cubic. All right, and let's, wow, I'm gonna zoom in a little bit on this portion here. I'm gonna put window size from -3 to 3. -3, oops, -3 to 3. And then I'm going to do zoom fit again. Whoa, I think I need to make it a little bit wider because I don't see any zeros here. So I'm going to do window, do -5 and 5, then do zoom fit. Oh, there we go. Okay, so there's my intersection. It looks like it's about, I don't know, it looks like it hits at 5 or something. Let's find out. We'll do second calc 0, enter, left bound. So I need to place the cursor somewhere to the left of this intersection. It's already to the left, so I'm going to hit enter. The right bound, I want to put it slightly to the right of the intersection, so slightly to the right of the intersection. And then it asks me for a guess. It doesn't matter where the guess is because there's only one intersection. If there was more than one intersection in the left and right interval that I specified, then I would need to put it close to the actual intersection. But since there's only one intersection, it doesn't matter. it finds that the intersection is 3.5 comma 0. Okay, so one of the roots is 3.5. Which root was that? It is this root here. So it's a good thing I didn't try to do this manually, because I probably would have tried all the whole number roots first before I finally got to the fractional roots. So yeah, that would have been a challenge. Okay, and so one of the roots is positive 3.5. And then to find the other roots, we could use synthetic division now. So if I put 3.5 here, and I put the coefficients, which are 2, -3, -4, and -35, 2, 7, 4, 14, 10, 35, 0. So my remaining coefficients are 2, 4, 10, which would lead me to 2x squared plus 4x plus 10. And the roots are going to be 4 times 2 times 10, 8 times 10, 80, over 2a, which would be 4. So -1 plus or minus. So that would be square root of 80 minus 16 is 64. So square root of -64, so that'd be 8i. 8 divided by 4 is 2, so it'd be 2i. So the other two roots are going to be imaginary. It's going to be -1 plus or minus 2i. Okay, so let's briefly look at E, rational roots theorem style. So if we look, we can see that the last coefficient or term is 6. The first coefficient is 4. So in order to generate the list of all possible roots, we would take the factors of 6, which would be plus or minus the whole number factors of 6, which would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. We would take the whole number factors of 4, which would be plus or minus 1, plus or minus 2, plus or minus 4. And we would take each factor of 6 and divide it by each factor of 4 to generate every single possible root. And one of those roots is going to pay off. Let's take, well, not like if there is a root, one of those roots is going to pay off. Okay. And since the book is asking us to do this, it will pay off because the book is going to give us one with at least one real root, okay? Okay, so we're going to put 4x cubed, 4x to the 4th. And again, I'm going to use technology because you are not responsible for you knowing rational roots theorem for the IB exam. And it's not something that's very fun to practice. And it's not really something that you need to practice. You just, if you know it, I think that you'll remember how to do it when the time comes. Plus x. You know, you might say, why the heck would I use rational roots theorem today? Well, you might use it in the computer program, right? If you write a computer program to find roots. Okay, x cubed minus 25x squared plus x plus 6. Okay, now I'm going to graph it. I probably need to fix this, but wow, there's lots of real roots here. Okay, so let's grab a couple of the real roots by zoom fit. Oh, I hate it when that happens. You like hope it'll get better, but okay. So let's do window, and in window we're going to go from -3 to +4. Window, -3, +4. Well, I need to do zoom fit again. No, it's not going to let me. Do it until it finishes. Zoom. If you ever want to like make it stop, just say second quit or turn it off, and then you don't have to wait for the graph to finish. Okay, that's better. Now there's a whole bunch. Okay, so clearly there's one at -2 and there's one at 3, right? So let's use synthetic division and find the last polynomial. Okay, so we're going to divide by -2. -2 is the root we're going to divide by, and we got 4, -4, -25, 1, and 6. We got 4, -8, -12, 24, -1, 0, 1, 4, -8, -12. Yeah, 24, -1. -1 times -1 times -2 is 2. 3, -2 times 3 is -6. Okay, something was weird. Okay, so I'm left with 4x cubed minus 12x minus 1 plus 3. Now I'm going to do synthetic division again because I know that one of the roots is negative or positive 3, right? So I'm going to put positive 3 here. And then I'm going to put 4, -12, -1, and 3. And so my remaining quadratic is 4x squared plus 0x minus 1. So I got 4x squared minus 1 equals 0. And so the remaining roots would be x squared equals 1/4, x equals plus or minus 1/2. Okay, plus or minus 1/2, 3, and -2. Those are the 4 roots for the quartic. Okay, so in 3, we are doing the exact same thing, except for this time they want us to give the answer in terms of linear factors and not the zeros. So let's do the first one. Again, you could use rational roots theorem and find out that the possible roots are plus or minus 2 or plus or minus 1. Let's just use graphing here. So first we're going to input the polynomial x cubed minus 3x squared plus 4x minus 2 graph. Okay, and let's find this 0 here. Second calc 0. Left bound, it's already on the left, let's move to the right. Guess. Okay, so there's a 0 at 1. So one of our roots is 1. And let's find the others by doing synthetic division. Whoops. 1, -3, 4, -2. 1, -2, -2, 2. Just watching my daughter this morning doing a bunch of long division problems. Do you remember doing that? Synthetic division is actually easier than long division, isn't it? I'm going to put x cubed. So our remaining polynomial would be x squared minus 2x plus 2. What's the discriminant of that? 4 minus 4. Okay, so that would be an imaginary number, or a complex number. So let's go ahead and use quadratic formula. Negative 2 plus or minus the square root of b squared, which is 4, minus 4ac, which would be 8, divided by 2a. So that would be positive 2 divided by 2, which is 1, plus or minus. Square root of -4 is 2i. 2i divided by 2 is 1i, so the other two roots would be 1 plus or minus I. They don't want the roots though. They want an expression. So I'm going to make an expression which is x minus 1, which is the first factor. And the second factor would be x minus 1 plus I, and the next one would be x minus 1 minus I. So look, x minus 1 plus I is actually x minus 1 minus I, right? And that becomes x minus 1 plus I. Okay, so that is the answer in terms of linear factors. I could put an A here saying, oh, I need to like figure out all possible polynomials, but remember, they already told us that this polynomial has an A value of 1. So we know that A is 1. Okay, let's do C. Okay, so first thing we're going to do with C is we're going to find at least one factor so that we don't have to use rational roots theorem and a bunch of synthetic division. 2x cubed minus 9. This is the advantage of me not making you do problems. You just do the amount of problems you think are necessary for you to get good at it. And you do it the way you think you need to get good at it. And then you're going to go to college, and then maybe some of the teachers are going to make you do exactly the problems that they think they want you to, that they think you need to do. Of course, usually in college they don't really. I'm going to do the window from -1 to 5, I think. In college, they like in college math or physics classes or whatever, they don't really ask you to do like an overabundance of problems. I mean, the homework's going to take you probably a few hours a week to do like 10 problems. So that's definitely seems like enough, right? But they're not going to ask you to do like in some math class where they ask you to do like, 20 of each kind of problem. They're only going to ask you to do like 1 or 2, but then on the exam you got to be able to do that problem, right? So we got at least 2 roots here. We're going to do second calc 0, and I'm going to move, let's find this one first. There, so like left, right, guess. So one of the zeros is 3.73. But did they say to find exact values? Okay. I can kind of tell what that's going to be, but let's try to find that one. Maybe that's kind of more of an exact number. Okay, so we'll do, let's move the cursor over here first. Okay, second calc 0. Oh, it doesn't remember that I moved the cursor over there. Thank you. Isn't this a great program from 1985 that's never been changed? Okay, so one of the zeros is 1/2. Okay, that's a nice even number. So for C, that was A here. Let's do C. So for C, we found out from technology that one of the zeros is 0.5. And now we can use synthetic division to find some of the others. 2, -9, 6, and -1. So I bring down the 2, multiply it times 0.5, we get 1. Add, we get -8, multiply that times 0.5, we get -4. Add, multiply that times 0.5, we get 1, 0. Okay, so we end up with the polynomial 2x squared minus 8x plus 2. That looks kind of like we can factor out a 2. And let's see, let's take the discriminant of that. 4 squared minus 4 times a times c. So that would be a irrational root. So let's go ahead and do quadratic formula. So the roots would be -4 plus or minus square root of b squared, which is 16, minus 4ac, which would be -4, b square root of 12, divided by 2. I'm ignoring the 2 here, okay? I'm just doing the roots for x squared minus 4x plus 1, a little bit easier. So that would be positive 2, because negative 4 divided by 2 is positive 2, plus or minus square root of 16 minus 4 would be square root of 12. Square root of 12 is 2 square root of 3. 2 square root of 3 divided by 2 is square root of 3. So 2 plus or minus square root of 3. So those are two roots, and this is one of the roots. So if I wanted to write it in terms of factors, first I would put the a value up front, 2, and then I would put x minus 1/2, because that's one of the roots, and I would put x minus 2 minus square root of 3, because that's one of them, x minus 2 plus square root of 3. So that would be my linear factors. If I wanted to, I could multiply the 2 times the first one, and I would get something that looks a little nicer. If you like whole numbers in your factor, I could put these two together, right? Otherwise, we're done. Shall we do e now? So e is a cubic. We'll put it in here. 4x cubed minus 8x squared plus x plus 3. Graph. Okay. I don't know, that looks like 1. Let's try to find that one. Second, calc, 0, left bound. Now it's kind of, on this one it's important to use guess correctly, right? Because, let's see, right bound, I'm going to put the guess, I'm going to put it on the left side of here so I make sure I get the, yeah, so I didn't want to get this one, I wanted to get this one, so my 0 is 1. So I can use synthetic division to find the others. So it's, I'm doing e right now, so it's 4, negative 8, 1, and 3. Bring down the 4, multiply, add, multiply, add, multiply, multiply, add. So one of my roots is 1. The leftover quadratic is 4x squared minus 4x minus 3. Let's look at the discriminant there for a second. So it'd be 16 minus 4 times, oh, so that would be imaginary, okay? So we definitely need to use quadratic formula. So negative minus 4 plus or minus the square root of b squared minus 4 times a times c. Well, maybe it's, I guess, you know, I thought it was imaginary, but look, there's a negative sign there. So like, actually it's going to be a positive number. Still kind of a mess. 2, and the denominator would be 2a, so it would be 8, right? So that would be equal to, we'll use this space here. Positive 4 divided by 8 is 1/2, plus or minus 16 minus, let's see, 4 times 4 is 16, 3 times 16 is 48, 16 plus 48 is 64, square root of 64 is 8. 8 divided by 8 is 1. So 1/2 plus or minus 1. So one of the roots is 3/2, and the other root is negative 1/2. Okay. And of course, the a value is 4. Don't forget that. So if we were going to write this out in terms of linear factors, it would be 4 times x minus 1 times x minus 3/2 times x plus 1/2. And you can use this 4, you could break up this 4 into 2 times 2, and then you could put one of the 2's, multiply it times this one of the 2's, multiply it times this one, and then you would get something that has whole numbers in it instead. So it would be 2x minus 3 times 2x plus 1. And there would be no a because we've already incorporated it into the other linear factors. Let's do g. So we got quartic 2 x to the fourth minus 3x squared minus 3x cubed plus 5x squared plus 6x minus 4. Looks like there's one at 1/2. Let's check it out. Looks like there's one at -1 too. So let's try to get the one at -1. It's a whole number. So let's do window. So I did window from -2 to 2. I got this. So let's try to get that one there. Second calc. Oops. Second calc 0. Left bound. We'll put the cursor to the left side over here. There it is. Enter. Right bound, we'll put the cursor. I think that's good. And then put the guess, put it on the left side. Make sure we get the left one. -1, so it is at -1. All right, so one of the roots for g is definitely -1. So we're going to do synthetic division with -1. And inside we're going to have 2, -3. They're really nice because they never skip one of the terms, which is one of the things that's easy to mess up on synthetic division when they skip a term. Oh, it's pop. What? Whoa. 5. -2, -2, -5, +5, -10, -4, +4. Okay, 0. Okay, so we got 2x cubed minus 5x squared plus 10x minus 4. Actually, there's one more real root here. It looks like it's at 1/2. Let's try to find that one. Second calc 0. You know, one thing I'm going to do is, let me just change the zoom a little bit because, not the zoom, but the window, because it's a little bit hard to see what's going on with. I'm going to change the y min to, let's see, instead of -5, I'm going to make it like, no, that's okay. I'm going to change the y max to +5 instead of 60. That'll improve it. Okay, now let's find this 0 here. It's a little easier to see. Second calc. Second calc. It just did trace instead. 0. Left bound. That's a fine left bound. It's already in the right place. Right bound. Go to the right of the intersection. Guess. 0.5. Okay. 0.5. 2, -5, 10, -4. So bring down the 2, multiply times 0.5, you get 1, multiply times 0.5, 8, multiply times 0.5. Oh, perfect. So then the leftover quadratic is 2x squared minus 4x plus 8. That's a root. That's a root. The last two roots, let's see, let's factor out a 2. We get x squared minus 2x plus 4. Let's check the discriminant. So that would be, the discriminant would be 4 minus 4 times 1 times 4. So that would be negative number, so it would be a complex root. So let's go ahead and use quadratic formula. Negative minus 2, negative 2, plus or minus b squared, square root of b squared, which is 4, minus 4 times a times c, all over 2. So negative 2 is positive 2. 2 divided by 2 is 1, plus or minus the square root of negative 12. So actually be root 12i, which is 2 square root of 3i. 2 square root of 3i divided by 2 is square root of 3i. Okay, so these are the other two roots. So the two roots, the four roots are negative 1, 0.5, and 1 plus or minus square root of 3i. We already factored out a 2 there, so we're going to have 2 times x plus 1 times x minus 1/2 times x minus 1 minus square root of 3 of I times x minus 1 plus square root of 3i. And we can factor this 2 out to here, so it would be x plus 1 times 2x minus 1, and then the rest of it's the same. Okay? So that's it.